note because I got caught up on this. When you count 3 days, if you have a class you're interested in on a Wednesday, you need to sign up on the Friday beforehand, because I just messed up and did not do that, because 3 days is Friday, Monday, Tuesday for the Wednesday class. So this is a change. So definitely plan ahead, look at the catalog. And if you don't have one in hand, look online to see what the courses are. You'll be able to tell online if you sign up online what courses are open and closed when you go to sign up. I'm delighted to see you all here and delighted to have Lori Dengler back. She's an emeritus professor of geology at Cal Poly Humboldt and an expert in tsunami and earthquake hazards. Since retiring in 2015, I don't think she's really retired, frankly. She continues to work on earthquake and tsunami preparedness efforts on the North Coast through the Redwood Coast Tsunami Work Group, and nationally as a member of NOAA's Tsunami Science Technical Advisory Panel. I want to welcome Lori, and we can all sympathize with her. She has caught a cold, so she'll be sipping her tea periodically. So thank you very much, Lori, for doing this under these circumstances.
Okay, let me first go back. Can everybody hear me?
I can. Can everybody else?
Okay. Let me first go back to the beginning of my presentation. That would help rather than starting at the end. And I certainly want to thank all of the OLLI folks for having me back again. I really enjoy this opportunity to sort of talk what's on my mind at the moment. And like many of you recently, what's been on my mind is a lot of North Coast earthquakes. So I always like to start my presentation with what you should do if an earthquake actually happens right now, which it certainly could. Most important thing is to not move while the ground is shaking. And for all of you able-bodied people, that means dropping to the ground, covering the back of your neck with your arm, and then scooting under a table or desk if one is nearby. If one is not nearby, just make yourself as small as you can. Hang on to the desk and ride out the earthquake. Stay there until the shaking is over. I hope that everyone who is listening to this talk is aware that if you live on the coast, there is a tsunami threat. And for a large earthquake, the shaking may well be the only alert that you get. And so if that shaking goes on and on and on, doesn't have to be strong. The important thing is long. That's your indication to head inland or to high ground if you're in a tsunami zone as soon as you can safely move, because every minute is important. Please go by foot. Roads are likely to be damaged, clogged, and may actually take you to a more hazardous area before you get to high ground. And once you are in a safe place, please stay there, stay there, stay there until you get some kind of official notification that it's safe to return. So really important to enjoy our coasts, but be aware of the tsunami threat and other threats such as sneaker waves, rapidly rising tides, and so forth. I go to the beach virtually every day on dog walks. I'm very aware of both the beauty and the potential threat. Thank you for acknowledging the people who came before us, and many of whom are still here now on the North Coast. There are actually many more different tribal groups than what most people mention. Some were quite small, some were relatively large. The native peoples were here for thousands of years before the advent of peoples of European ancestry and writing. And they have much more to actually say about past great earthquakes than any of us do because they experience them. And I will get back to part of their story later on in this talk. So what I'm going to do in this talk is give you a historic perspective of earthquakes, seismology, seismic hazard assessment, really by taking you through different historic periods, because our perceptions of earthquake threats are very much limited by the historic window we're looking at. They're limited by what kinds of seismic instruments that we have, and they're also limited by our imagination. And that turns out to all be very important. So I'm going to focus the first part of my talk on the instrumental and written historic period. And first, I want to make it clear that this period is not any more important than times previous, but it's certainly the easiest to access historically because we have words on paper. This particular graphic shows earthquakes of probable magnitude 6 and larger that have affected the North Coast since 1900. The ones with little red diamonds beneath them actually cause significant damage. So a couple of points about this graph. Not all damaging earthquakes are centered locally. In fact, the first one on this that occurred in April of 1906 was centered near San Francisco. We'll get back to that in a little bit. It actually caused stronger ground shaking on the North Coast than any other earthquake in this historic written record period. Another thing I want to mention is that not all damaging earthquakes are on this graph, because some of our damaging earthquakes were smaller than magnitude 6. 1996, we had a magnitude 5.4 just offshore of Eureka that did a lot of damage. And maybe some of you who are listening in today experienced the 5.4 on New Year's Day this year, centered near Rio Del, that for some people produced stronger ground shaking than the 6.4 earthquake on December 20th. I'll get into the recent earthquakes later on in this talk. I also want to note, if anyone has questions, put them in the chat. Somebody else can take a look at them. I'm not very good at multitasking, especially with a foggy cold head. So I will try to respond to your questions at the end of the talk. So the written history of Humboldt Bay begins in 1849. And I'm really sort of focusing primarily on the Humboldt Bay region because that's where the majority of folks in Humboldt County live. Certainly other parts of the North Coast were settled. I don't like the word settled, but settled earlier than this. But in 1849, we have a group of 8 miners heading from kind of east of Weaverville, who decide in November that they don't want to take the overland route back to the Bay Area. They want to see if they can get to the coast. The fact that they've decided at the last minute to do this in November gives you a pretty good idea of just how bright they were and how well they had planned out their trip. They thought it would take them 8 days. It took them 6 weeks. And by the time they stumbled to the coast, they were starving. They were not in very good shape. They wandered around a bit. They made it up to Big Lagoon. And on Christmas Day, from the diary of the Journal of L.K. Wood, they were camped on the shore of Humboldt Bay, kind of near where Arcata is now. And they met a very friendly and welcoming Wiyot elder who provided them with food, and I think may have told them about Wiggy. Wiggy is the Wiyot name for Humboldt Bay, that it was created in a single day by an earthquake. We'll get back to that part of the story a little later also. It's amazing how quickly settlers followed the Gregg Party. Within a year, we have numerous settlements on Humboldt Bay. This is an 1850 map that is in the wonderful book by Ray Raphael and Freeman House, Two Peoples, One Place. I strongly encourage anyone to look at that book if you're interested in two different perspectives of Humboldt County history. Certainly within that first year, we have the settlement of Uniontown, which will later become Arcata. We have Eureka, we have Bucksport, we have Myers Landing that will become Southport Landing, and perhaps others. These were the ones I was able to grab quickly. Now, the settlements are important because the settlers brought with them newspapers, and there were lots of newspapers. There were newspapers that that didn't even make the list. Some of these newspapers only lasted a few weeks. The reason that newspapers are important is that prior to seismic instrumentation, this is our primary source of information about past earthquakes. And so I call this the pre-instrumental era. And we've actually been blessed on the North Coast, both in the past and at the present day, of having multiple newspapers in print. And the Humboldt Times in particular, 1854 through the present, starting in 1967, merged with the Humboldt Standard to become the Times Standard. That archive is really rich, and the Raphael and House also acknowledge the importance of having those archives, but there are many other newspapers as well, some of which were fleeting, others that lasted for a long time. And from that early record of newspapers, we can make a list of earthquakes. And I note that this particular list here, the magnitudes are estimated based on the felt pattern. So let's say we know how the 1992 Cape Mendocino earthquake, the pattern it was felt, how far away people felt it from the epicenter, how strong the shaking was near the epicenter. By calibrating the magnitudes from modern earthquakes and their felt patterns, we can go back and map out how an older pre-instrumental earthquake was felt and make an estimate. So all of these magnitudes are estimates, and many of them are probably larger. If you'll note from the figure, all those little circles, like these are the epicenters, and almost all of them are right on the coast. Now, what we know today is that almost all of our earthquakes are offshore, but we don't have any felt reports from starfish. So if you're just using felt reports to locate an earthquake, you're going to tend to locate them on land. It didn't take long in the written history of the Humboldt Bay region to record a strong earthquake. In October 1853, a report of an earthquake of pretty strong shaking in the Eureka area. The wharf reportedly sank 4 feet, and one drunken reveler allegedly drowned in that process. So it's really kind of interesting to read about these old earthquakes from the perspective of the effects rather than just numbers. So we've got a mill damaged, we have brick houses damaged. I doubt you'd have an earthquake today where the milk was thrown from pans. So we're going to quickly jump into the next era, which I call the early seismology era, from 1900 to 1932. So the first seismograph in the Western Hemisphere was in 1887 at Mount Hamilton in Berkeley, shortly followed by another instrument at the University of California at Berkeley. But for most of this time, 1900 to 1932, all of the seismic instruments are centered well to the south of us. We don't have anything in Humboldt County. And so when you look at the map of the earthquakes, we see now some of those epicenters are offshore, which is where they belong, because that is really where most of our earthquakes, as we know today, occur. And by just using data from those faraway seismic stations, you can roughly estimate where they are, but you don't have a whole lot of constraint because you don't have any instruments nearby. There are actually some very interesting earthquakes in this list, and I'm going to go into one in particular, the 1906 so-called San Francisco earthquake. Now, this map shows you where the epicenter was located, and the epicenter was just off of the Golden Gate. And that was the spot where the rupture began. But it doesn't show you the whole earthquake, because for big earthquakes, the epicenter, the rupture then proceeded to grow. And in this case, it broke all the way to the north to Cape Mendocino, and it broke all the way to the south near Santa Cruz. So forget the spot on the map. That the source of the seismic waves was that whole line, about 250 miles worth. So this is a US Geological Survey analysis of the slip in the 1906 earthquake. And again, the epicenter is just offshore of San Francisco, close to where it says 12. 12 means there was 12 feet of slip in the vicinity, on the San Andreas Fault, in the vicinity of San Francisco. But that slip is by no means uniform. You can see that the highest slip anywhere was near Point Reyes, where we have 21 feet. So if you'd been standing on one side of that fault and the rupture happened, suddenly you'd be 21 feet away from what you had been looking opposite beforehand. But if you go up to Cape Mendocino, you can see some of the largest numbers, estimated as high as 18 feet of slip in the vicinity of the what we call the Mendocino Triple Junction, where the San Andreas ends, where the Mendocino Fault begins, and where the Cascadia Subduction Zone begins. So the so-called San Francisco earthquake, a much better name for it would be the Great Northern California San Andreas earthquake, because Santa Cruz to Mendocino County got nailed by it. We're also fortunate in 1906 that there was a very skilled photographer living in Ferndale. Edna Garrett lived with her husband, who was also a photographer, and they were very rudely awakened in the early morning hours of April 18th. And unlike her husband, who I have no idea what he did during the earthquake, Edna grabbed her photographic equipment, which in 1906 was, it wasn't grabbing your cell phone, and she documented the impacts in the Ferndale area. And there's some of the most wonderful photographs from 1906 that I know of. And so we know a lot about the damage in Ferndale in particular in 1906. This was called the Whitefront store, one of two brick buildings in Ferndale at the time. It was so badly damaged that it actually was torn down after the earthquake. And this is near Port Kenyon on the banks of the Eel River, some of the most spectacular liquefaction effects that I've seen in any photograph. And I love their field clothes. And what happens when you have long duration shaking is that saturated sediments are weak and they tend to spread. And you get this kind of what we call spread failure. A number of years ago, I wrote a paper on the 1906 earthquake in Humboldt County and compared it to the 1992 earthquake, which some of you, I expect, experienced. The 1992 earthquake was very strong ground shaking. These two maps show what we call isoseismal or relative shaking maps. And the important thing to take home with these pictures is the pink, where it says the Roman numeral 9, is very, very, very strong shaking that's strong enough to even cause some damage to well-built structures. And it's going to just nail a poorly built structure. The yellow is intensity 7. And that's kind of easy to map because intensity 7 is the level at which you start knocking down chimneys. And by reading through these old newspapers, you could go, lots of chimneys down in Eureka, every chimney down in Petrolia and Ferndale, some chimneys down in Arcata and Blue Lake, and north and east of Arcata and Blue Lake, no chimneys were down. So it was fairly easy to draw that line, what we call an isoseismal line, for intensity 7. We have much better data, of course, for 1992. I think I had over 6,000 felt surveys to plot the data of. And if you compare these two, look at the size of the intensity 9, really strong shaking, all of Cape Mendocino, Ferndale, Petrolia. In 1992, it's just a little tiny thumbprint over Petrolia. And if you look at the yellow zone, chimneys were down in much of populated Humboldt County at the time. So my contention is that 1906 had the largest footprint of strong ground shaking of any earthquake on the North Coast in our written historic period. Now we're going to move to what I call the early instrumental period on the North Coast. And it begins in 1932-33 when this monster seismograph, there were actually 2 of these, were installed at the Ferndale Firehouse. This is state-of-the-art, early 20th centuries. These particular seismographs were at Mare Island in the Bay Area for a long time. They recorded the 1906 earthquake. And then they were kind of mothballed because they were considered by the 1930s to be obsolete. A young man in Ferndale was fascinated by seismology and communicated with the then director, Perry Byerly, of the Berkeley seismological laboratories, and managed to arrange to have these two horizontal instruments measuring the side-to-side motion of the ground brought up, refurbished, and installed in Ferndale. They continue to operate to this day. They were part of Berkeley's network until the 1960s. At that point, they were donated to the Ferndale Museum, and you can still go see them today. They're fascinating to look at. They don't have a lot of sensitivity, and they're a royal pain to keep up, because if you look down here on the lower part, they make their record by scratching a trace. There's a little needle that scratches the trace in a smoked paper drum. And that has to be done every day. You have to smoke 2 drums, because there's 2 instruments, and carefully line it up and set it out. Now, I'm calling this early instrumental period from 1933 to 1974, and we slowly gain a few more instruments in that period. But for much of it, we basically have the instrument at Ferndale, and we get instruments in Founders Hall at Humboldt. So we have 2 instruments up here, which is better than none, but we're still pretty far behind the rest of the state. In this 1933 to 1974, something's going to change in 74, which I'll get to in a moment. We certainly have a number of earthquakes, and I haven't included the smaller ones. On all these lists, you can see that I include both an estimated magnitude, and these estimated magnitudes are now pretty good because they are recorded on instruments. The intensities have to do with how strongly the ground shook. Intensity 1 means it basically wasn't felt. Intensity 7 means some chimneys were down. Intensity 8 means we have significant damage. Now, there's one intensity 8 here, a 6.6, on December 21st, 1954. That is a really interesting earthquake, which is shown right here. These are 2 photographs from the Times Standards archives. Of course, at this time, it was still just the Times, or maybe it was the Standard. I don't know who printed these particular photographs showing damage in Eureka. And on the right, you can see where the epicenter was, just, we think, south of Blue Lake. Over 2.1 million damages. The main water line that ran from the Mad River behind Arcata to Eureka was severed, was damaged. And there were reports from many fishermen that the Mad River flowed backwards because this earthquake happened in the day, and it happened at a time of year that people like to fish. This was a fascinating earthquake to me for many reasons, because first of all, it's on shore. And if you look at this map, you can see that there are these little red lines. Those are mapped surface faults. And we've had no historic earthquake on any one of these mapped surface faults. We have lots of mapped surface faults, and you'd expect our earthquakes to be on those faults. We'll get into this in a little later, that our layer cake geology here is a lot more complicated. This 1954 earthquake, for a long time, we thought might be on a surface fault. There was some data that suggested it was shallow. More recent analysis suggests probably not, probably similar to what happened in the more recent earthquakes, relatively deeper earthquakes, well below the map surface faults. We don't know for sure. So in this early instrumental period, 1933 to 1974, we've got reports from the Berkeley Seismological Laboratory that these 2 maps here are earthquakes mapped over decades, 1940 to 49, 1950 to 59. And when you zoom in and look at our North Coast earthquakes, you'll see that they look like they're kind of evenly spaced. That's again because locations just aren't very good. They've been rounded off. And keep this picture in mind when we start looking at more recent earthquakes. So there's some things that happen between, well, prior to 74 that are going to be important, especially in the 1960s. So in the 1960s, we have the advent of plate tectonics, this idea that the outer part of the Earth is in kind of constant motion, driven by the heat within the Earth. And most of these sort of chunks of the outer Earth that we call plates or lithosphere are relatively tectonically quiet. In other words, we don't have earthquakes or volcanoes or current mountain building going on within them. And most of that tectonic activity is occurring along the boundaries. So certainly by the early 1960s, we recognize, well, we also have some good bathymetric maps of the sea, the shape of the seafloor. So this figure to the left is a bathymetry map based on soundings of ships going by and pinging off the seafloor, showing the relative depths to the seafloor surface. And you can see that it's really unusual off of our coast. Cape Mendocino is a remarkable boundary between where we have very deep ocean crust, the top of the crust, and the very shallow Gorda Basin. Now, the Gorda Basin got its name much earlier from the early settlers, particularly from the Azores, the fishermen, who named it Gorda for fat because this was a great place to fish compared to further south where the ocean is much deeper. You can see in the bathymetry 3 of our plate boundaries that certainly by the middle 60s were fairly well understood. We have the Gorda Ridge far offshore where the 2 plates are spreading apart. We have the Gorda Escarpment and the Mendocino Fault, which is a transform boundary where the 2 sides are moving side to side. And then basically at the base of the continental shelf is what we call the Cascadia subduction zone, and where this offshore Gorda plate and to the north Juan de Fuca plate are being pulled beneath the overriding North American plate. And on the right, we have just a simple color code that everything in red is the North American plate, everything in green is the Gorda Juan de Fuca plate, everything in yellow is the Pacific plate. And where those 3 colors come together is the Mendocino Triple Junction, which, not surprisingly, is an exciting place to be. Now, as more understanding of plate tectonics filtered into the literature, and certainly by the late 60s, not everybody was a true believer yet, but certainly by 1970 there were. And this, I've grabbed 2 figures, parts of 2 figures from a 1968 paper published in the Bulletin of the Seismological Society of America by Bolt, Lobnitz, and McEvely, 3 researchers, professors that I knew at Berkeley. And you can see 2 maps here that are showing these funny looking beach balls, one off the North Coast and one in the greater San Francisco Bay Area. And at first glance, you should sort of notice that the majority of these funny little beach balls on both maps look the same. You see 4 quadrants, 2 white, 2 black, and they're all kind of tilted in the same direction. These are called focal mechanisms or fault plane solutions. And by the 1960s, seismologists understood that we could figure out which way a fault moved by looking at the very first motions of the seismic P wave, the first P wave that comes. If the first P wave is a push or the first P wave is a pull, and we plot those out, we can actually go, oh, this was a strike slip fault. Oh, this was a thrust fault. And lots of grad students were doing this in the 60s when I started my grad studies at Berkeley. And this particular paper contended, from looking at these, what we call beach balls, hey, they look just the same. And so we think the tectonics of the San Andreas system are breaking through the Gorda Plate. That's what's explaining this earthquake activity. We'll get back to this in a minute. And when I came up to Humboldt in 1978, there were still some discussion by some people that this might be the story. Now, there's another big player in the history of seismology on the North Coast, and it was sort of an unwilling player. PG&E establishes their Humboldt Bay unit number 3, the first nuclear power plant in California, the second in the country, second or third, depending on how you count, at King Salmon. And it's built with a fair amount of county fanfare. There's really not much local opposition until the 70s. And if you're interested in more of this story, you can go to the Brown Bag Archives. I believe I did this in 2022, and you can pull up the talk that I gave about the history of the power plant. Now, as I say, unwilling, this is actually a slide straight out of that old OLLI talk, where I'm looking at the period between 1970 and 1980. And there are a lot of things that happen that are going to affect nuclear power, and particularly the Humboldt Bay plant. The 1971 San Fernando earthquake produces surface fault rupture, and suddenly the whole country is really concerned about surface fault rupture. We have an earthquake that occurs near Fortuna. It's not very big, but it produces fractures, and it's only a couple of miles from the power plant. And then some surface faults are found even closer to the power plant. So the Atomic Energy Commission, which is what it was called at that time, basically requires every nuclear power plant in the country to assess the seismic hazards associated with the plant. So 1974, Terra Corporation establishes a regional seismic network. And that's where I call the next seismic era, the Humboldt Bay Seismic Network from 1974 to 1986. So you can see on the right a map of the 14 stations that they established, permanent stations, at least permanent for that period, 74 to 86. And then they produced reports. This was the very first one that they produced. And suddenly we see a very different picture of the seismicity. We're now able to pick up small earthquakes, especially small earthquakes close to the coast. So this is now a map of magnitude 3 and larger earthquakes, a lot more detail that we're seeing. And we get better locations of certainly the larger earthquakes. There's one very important earthquake that happens during the Terra era, And it was the very first North Coast earthquake I experienced, November 8th, 1980, a magnitude 7.2, just offshore of Trinidad. And I'm living right there where the arrow is at that point. Almost as close as anyone could be to the epicenter. But just like 1906, the epicenter isn't the whole story. The earthquake started there and then proceeded to rupture all the way down to the Mendocino Fault. And from this earthquake, we could tell very clearly that it was a strike-slip earthquake, but the motion was exactly the opposite to what you see in the San Andreas Fault. So San Andreas Fault earthquakes would be rupturing in this direction to the northwest. This is clearly rupturing to the southwest. So it's what we call a left lateral strike-slip earthquake, and this puts to rest the notion that the San Andreas Fault is punching through. The earthquake did cause major damage to the 101 Tompkins Hill overpass, largely because it was a bridge that hadn't been retrofitted to resist shaking. The Terra data suddenly shows us, I mean, it's kind of like before we just saw a great big blob, now we can start to see details. And we can start thinking about our structures in 3 dimensions. So this is out of Bob McPherson's work. Bob was my first master's thesis student at Humboldt, and he ran the Terra network for the entire period it operated. And what he's done is he's taken this east to west slice shown in the upper picture, and then all the earthquakes on that slice, he's plotted them as a cross section. And we can now actually see this dipping pattern, this dipping zone right here. That's the interface between the overlying North American plate and the underlying or subducted Gorda plate. And you'll notice from this is that there are way more deeper earthquakes down here in the Gorda plate than there are up here on the North American plate. Those map faults that I showed you on the 1954 graph, the map, those are based faults on the surface. They don't see the faults down here at depth. So this is the work that really made us start thinking, oh, we've got to think in 3 dimensions. So now let's go into our, quote, modern era. And I need to preface this by saying our modern era is constantly evolving. We're getting more seismic stations, higher quality stations, and newer ways to look at the data. So it's not like everything since 1986 has been the same. We've also had a really significant run of earthquakes, particularly in 1992. So let me talk a little bit about the Cape Mendocino earthquakes, since I certainly experienced them and maybe many of you did as well. A very memorable Saturday and early Sunday, 11:06 a.m. I know exactly where I was and what I was doing, getting ready to go on a picnic with my family when the ground started shaking. And I counted the duration of shaking and it was 65. By the time I got past 40, I knew that my picnic was not going to happen that day. About $60 million worth of damage in Humboldt County, concentrated in Ferndale and Rio Dell. Below, you can see the seismogram of not only one earthquake, that was our 7.2. Then we had 2 aftershocks, one at 12:41 a.m., one at 4:18 a.m. They were offshore, and they were actually very different kinds of earthquakes. Number 1 was shallow on a fault within the North American plate. Number 2 and 3 were deep in that subducted Gorda plate, in that band of Bob McPherson's really thick seismicity. And it really illustrated the complication of earthquakes in the vicinity of the Triple Junction. Here's a brand new kind of slide. And the first time I'm mentioning tsunami since about the second slide of my presentation. The 1992 earthquake produced a very small tsunami, but it was recorded on tide gauges in Humboldt Bay, Crescent City, as far north as Southern Oregon. It was recorded in Hawaii and along much of the California coast. And the tsunami, this is what's called a merogram. It's showing the water level as a function of time. And the reason it goes up and down is because that's high tide, that's low tide, high tide, low tide. The earthquake occurred about 47 minutes before the tsunami was detected in Crescent City. 47 minutes may sound like a lot, but it's a real big deal when you're talking about tsunamis. And it's certainly arrived much earlier in Humboldt Bay and in the Cape Mendocino area. We call this a local or near source tsunami. And this really changed the course of our thinking about tsunami hazards in California. We'll jump to the 2010 Eureka earthquake, located about 15 miles offshore of Eureka, magnitude 6.5. All of these red circles are damaged structures in the city of Eureka. Most of them are damaged chimneys, like that photo on the right. Some of them are damaged to foundations and so forth. That earthquake caused about $40 million worth of damage. We're very fortunate that it wasn't a little bigger or a little closer. Now we move into the last 2.5 years, 3 years, and the activity between December 21 and to the present, where we've had a number of interesting earthquakes. We'll start on December 20th, 2021. I'm just using the USGS numbers here. We actually think some of these magnitudes may change. A 5.7 offshore, a 6.2 onshore, and then a year to the day later, a 6.4. And then some of you may have felt some of these earthquakes that have just happened in the last couple of weeks. We have much better instrumentation and methods of analysis right now. And this is data from Anthony Lomax, who we've been working with on the December 20th earthquakes. And up here in the upper left, you can see the two, roughly where these two earthquakes were centered. The first one, both are occurring at about 12:10 a.m. They're 11 seconds apart. And for about 3 weeks, they were published as a single earthquake. The first, the earthquake on the Mendocino Fault, located relatively shallow, centered here, and it ruptured this little red zone right here. And then we had 11 seconds later, a very, very different earthquake, an earthquake that was quite a bit deeper on a fault, deeper fault within the Gorda Plate. Then we have, a year later, we have, remember the earlier earthquakes occurred over here on the Mendocino Fault and occurred over here very near Petrolia. Similar earthquake happens to the second, the bigger earthquake. We think they actually may have been about the same size now. on December 20th of last year. And we have the turquoise shows the epicenters and the red shows the calculated slip. Roughly 10 miles of a fault slipped. And we can see now the details of the structure so much better than we could only a decade or two ago. This puts all of these earthquakes of the past 3 years into a single picture. And now it's not a cloud anymore. We can see individual fault structures. We can see the Mendocino Fault. We can see these fault structures offshore that extend offshore. Here is the 2022 earthquake. And we're beginning to realize that these deeper earthquakes that we can't see the fault exposure of on the surface are behaving in the same way. They're repeating, they're producing earthquakes that occurred on the past will occur in the future on these planes of weakness. The 1975 earthquake, we think, ruptured this same plane. We see activity up here on the 1980 rupture plane. Who knows? Another 7.2 might be just around the corner. And we're also seeing what suggests is a big shift in the seismic pattern, starting with the 2021 earthquake. This is a plot that Peggy Hellweg put together from Berkeley data that shows earthquakes as a function of depth. So here's the surface up here at 0. These are in kilometers. So 20 kilometers is roughly 12, 13 miles. We see lots of earthquakes right along here. We see a smattering of somewhat bigger earthquakes. And then we have a gap for almost 2 years. When that December 20th, 2021 earthquake happens, suddenly we're getting more earthquakes, we're getting deeper earthquakes. And big question is that going to continue? Or is it going to then quiet back down to this sort of background pattern we saw here? In the last sort of 10 minutes of my talking part of my talk, I am going to switch gears. We've really focused on how we've gone from written records up to better and better seismic information to get a better and better picture of the earthquake activity of the present day. None of those earthquakes in our written historic period occurred on what we now think is our largest fault and our greatest threat. But if we go back to those very early days of first contact, we see that the Wiyot people knew all along that there was a bigger threat. This is a piece from the Humboldt Times, 1855. The newspaper isn't even a year old when this particular article, found by Deborah Carver, who's been compiling the oral history of the native peoples of the North Coast for decades. And in this article, they're talking about how the Wiyot had gathered together to perform what we would now call a world renewal ceremony, which is to put the earth back in equilibrium. The Wiyot, the Yurok, and certainly other peoples in the Pacific Northwest all had emergency response mechanisms when there were strong earthquakes. And one of them was to sort of recenter the earth, keep the earth from tilting. When the earth tilts, you get tsunamis, and those aren't good. At this point, no one in Humboldt, none of the white settlers knew anything about tsunamis. But Basically, in 1855, they're recounting a story of the Wiyot holding a renewal ceremony to level the earth. Why? Because the bay was created in a single day in an earthquake. So you got to keep everything level because that isn't great. That was really thought about as being a kind of quaint story for a long time. But in the 1880s, geologists started taking this much more seriously with the advent of what we call paleo tsunamis. So on this graph, we can see the historic record of tsunamis and then a whole bunch of question marks about what may have happened in the past. Paleoseismology is a way of looking for geologic evidence when you don't have a seismograph that an earthquake may have happened. And there are a variety of techniques. This illustrates how coastal land levels change in big earthquakes. And certainly if you look at what happened in Alaska in '64, in Chile in 1960, in Japan in 2011, we know that these big earthquakes on subduction zones have a very characteristic pattern of land level changes. So on the coast before the earthquake, you might have a tidal marsh. The earthquake causes the land to suddenly drop, depositing tsunami, dropping the land. Suddenly you no longer have near shore coastal species, and you may have tsunami deposits added. And then many years later, that whole sequence gets buried. And over on the right, you can see an actual exposure from the Oregon coast that shows this characteristic pattern of sudden subsidence, deposition of sand sheets, and then the building up of a new layer. Here shows, based on these sort of subsidence and other paleoseismology records, we've actually been able to push the record of past big earthquakes back about 10,000 years, maybe even further than this. Is an older slide, but people working up and down the California, Oregon, Washington, and British Columbia coast have compiled all of this data of sudden submergence or strong ground shaking. We've also started taking the oral history of the native peoples much more seriously. And whoops, I don't want that yet. On the left shows tsunami stories in blue from the native people. In gray show actual physical evidence of tsunamis. We also have written records from Japan that talk of a tsunami that was not part of an earthquake. People didn't feel the earthquake. They just suddenly, the tsunami appeared. And by analyzing a number of locations on the Japanese coast, we're now pretty darn sure that a magnitude 9-ish earthquake happened in the winter, January 26th of 1700. And based on the size of the tsunami, it was likely a magnitude 9, based on the area that we see the paleoseismic information. So this has now become pretty much accepted for everyone from Northern California to Vancouver Island, Canada, that our largest threat is a repeat of what happened in 1700, or a somewhat larger earthquake, or a somewhat smaller, but something in the magnitude range of 8.5 to maybe 9.1. Can't really squeeze in a bigger earthquake. And that earthquake would involve a fault that's sort of the shape of the red right here. A couple of things you'll notice about this is that it's not of uniform thickness. It appears to be much wider off of the Washington coast. It's also, a lot of it is onshore when you get to Humboldt County, and that's going to have an effect both on the size of the tsunami and the amount of shaking. So compared to offshore Oregon and Washington, we actually expect the tsunami to be somewhat larger. The ground shaking probably not as bad, but we're still talking about a significant tsunami, and a tsunami that, because we're so close to the source down here, is going to arrive in as little as 10 minutes. Strong shaking throughout this region, a tsunami damaging Hawaii and Alaska and countries throughout the Northern Pacific. I'm going to sort of finish my talk with not burying your head in the sand. Just because we have a really large earthquake threat does not mean there's nothing we can do about it. In 2005, I was part of a post-tsunami survey team in Indonesia, and I spent 2 weeks visiting areas along the Aceh coast where 95% of the population had perished. This was a 9.1 earthquake. Tsunami arrived in some places as little as 8 minutes after the shaking began, and it was horrific. The last place we visited was the community closest to the epicenter of the earthquake, a little town called Langi Village on the north coast of Simeulue Island. They felt the earthquake. The tsunami arrived 8 minutes later, continued to arriving for many hours, and the largest surges were 45 feet high. It completely destroyed Langi Village, but not a single man, woman, or child perished. Why? The Simeulue Islanders have an intact oral history that goes back at least 5,000 years. And it includes past earthquakes, past tsunamis, and they have a word for it called smong. A smong is the whole shebang. It's feeling an earthquake that lasts for almost a minute or longer. It's seeing the coastline change its shape. It's observing tsunami surges that arrive for a day. And what do when they feel those earthquakes? They all, they grab the children, they put Granny in the garden cart, they go up the hill where they've been storing supplies, and they stay there for a week or two. And they've been doing this for over a century, since their last big tsunami occurred, 5 generations without a tsunami. And yet, when I asked them, aren't you concerned about a false alert? They said no. They laughed. They said every earthquake is an opportunity to practice our evacuation skills. So I always like to start by saying, if the Simeulue Islanders can do it, so can we. If we're talking about a really large earthquake, another earthquake like 1906, 1992, well, we should have some sense of what's going to happen. Disrupted communication, disrupted transportation, isolated islands of humanity. The earthquakes of the last couple of years haven't done that. They really haven't disrupted our communication or our ability to move from one area to another. But a larger earthquake certainly could. Aftershocks, we're still in the aftershock period of the 2022 quakes. Rumors, misinformation, that's worse than ever in this era of social media. Getting people to do the right thing in the earthquake. We were very fortunate last December. The earthquake happened when almost everyone was asleep. And the shaking was so strong, they couldn't do anything. They were in bed, they were kind of stuck in bed. And as a result, nobody got injured. Similar sized earthquakes in 2010, we had hundreds of injuries. We had 17 injuries last December. Why? Because they couldn't move. They couldn't run outside. The worst thing you can do while the ground is shaking is to run out the door. So participate in the shakeout. I hope everybody who is involved today, including the OLLI staff, signs up, registers as participants at the Great Shakeout, which will be this October 19th at 10:19 a.m. Listen to KMUD and you'll actually get a broadcast as the shakeout time happens. Plan ahead and be prepared to be on your own. The next great tsunami is not likely to be generated from here. It's probably going to come from far away. It could come from Alaska, Japan, Chile, or anywhere in between. Here you have to rely on tsunami bulletins, what they mean. Go look at one of my last year, earlier this year, last spring semester, I gave an OLLI talk on the Tonga eruption, talked a lot about how the tsunami warning system works. So understanding what bulletins are, signing up for emergency notifications, know how to follow instructions, basically. Next March, assuming that we don't have a government shutdown, which is not something you can assume anymore, we will be holding last week of March another countywide tsunami notification communication test. The one that certainly makes most of us in the emergency response community most nervous is a repeat of Cascadia, when we have an earthquake and a tsunami together. And here, once again, we got to get people to do the right thing. But we're not going to be able to give anybody any guidance because communications will be down. Probably won't be able to drive your car. You're not, for hours or maybe even days, you're going to be in the dark. Now, I know that there are some radio stations that are working really hard to be hardened and self-sufficient. So certainly have a portable radio station and scan the dial to see if somebody is on the air. But be prepared to be completely on your own, cut off in your own neighborhood for days. And if you're in a really remote area, for weeks. Know if you're in a tsunami zone. Be prepared to shelter in place for days or weeks if you're out of the zone. And stay away from the coast until the danger has passed. And I love this photograph showing the middle school and elementary school children from Unusumai in Kamaishi, Japan, evacuating during the 2011 tsunami. Evacuating because they've had training with absolutely no prompting from their teachers. In fact, their teachers were sort of hesitant, saying, oh, we should just maybe stay here, we'll be safe. The kids did not. And not a single one of these children were injured in the 2011 tsunami. As usual, there are all kinds of organizations which stand behind me when I talk. Part of the Redwood Coast Tsunami Work Group, but I particularly want to note Ryan and Troy at the Eureka National Weather Service, Amanda at Cal Poly Humboldt, Rick Wilson and Jay Patton at the California Geological Survey, Peggy Helwig at UC Berkeley, and Yvette, wonderful Yvette at California Office of Emergency Services and her staff who continue to support us, and my gazillion friends and colleagues at the Redwood Coast Tsunami Work Group. Things keep happening. And so please Follow us on Facebook. You don't even have to be a Facebook user to see the Redwood Coast Tsunami Work Group page. That's where I tend to post things as they're happening. And then also the Redwood Coast Tsunami Work Group webpage. And I'm going to end it right there.
Lori, you have a number of questions.
Okay, let me stop my share.
Yeah,
Okay.
you're in luck with your cold. You only have 4 or 5, 3 actually. Indigo asked, how can we determine how fast the tsunami will arrive on the coast by how long the shaking lasts?
That's a good question. And I actually can give you an answer. Time has nothing to do with how long the shaking lasts. A small tsunami travels at exactly the same speed as a large tsunami. The only thing that's important is how far away it is from you. So when you feel an earthquake, like many of you did last December, your only cue is how long that shaking lasted. And that's not telling you how far away the tsunami is, it's telling you how large the earthquake is. That earthquake I didn't feel because I was in Sacramento getting a new car that night. But I do know several people. I mean, I know many people who felt it. And Troy Nicolini at the Weather Service was at home asleep on Fairhaven. And he's very concerned about tsunamis. And he and his wife and his son and his brother and their dogs all were out the door and up to the high dune behind their house within 4 minutes of the shaking. By the time, it was probably a tweener kind of earthquake. The strong shaking lasted a count of about roughly 15 seconds. It certainly wasn't over instantly, but it also didn't go on and on and on. I have another friend, Jay Patton, who lives on the peninsula, who said from his perspective, the earthquake was over too quickly. I always say, when in doubt, drill it out. The important thing is to recognize the shaking is your alert. And the nice thing is that if you're dialed into radio stations, particularly KMUD, they're great. KHUM, sometimes good, sometimes not so much. Forget KHSU, they're useless because they don't have anybody on staff to get info out quickly. The National Tsunami Warning Center issued an alert 5 seconds after that earthquake that there was no tsunami threat. So by the time Troy and his family were sitting on the dune, they got the text message that there was no tsunami threat. And they all felt great because they had practiced the muscle, developed the muscle memory to do exactly the right thing had there really been a tsunami.
And Ann Pearson has a question.
Yes, my experience has been that the earthquakes I experienced when I was younger were rolling ones, and the more recent ones were more jerky. And I was wondering the why of that.
Great question. And it has to do with 2 factors. One, obviously the location of the earthquake, how far away it is from you. And 2, the characteristics of rupture. So let me talk about 1980. That was my first earthquake. The rupture was very close. The epicenter was really close to where I live. But then it proceeded to rupture away from me to the southwest. That earthquake felt very rolling. I mean, the house screamed. It was kind of no fun to wake up to, but it was a real rolling ride. The fact that it was rupturing away from me was what we call the Doppler effect. And if you're kind of aware of what happens when a train is coming at you or a semi, If it's driving towards you, what happens is the waves, the sound waves that are traveling out from it are bunched together. And you hear that in getting higher in pitch and actually louder. When it goes away from you, the opposite thing happens. So you hear it getting lower and lower in pitch. That's just like the waves getting more rolling. So 1980 was a very rolling earthquake because it was actually rupturing away from us. Our offshore earthquakes all tend to be somewhat rolling because they're already pretty far away from us. We had one in 2013. Because the earth acts as a filter. It's just like, you've got your upstairs neighbor has a huge stereo system, and you only hear the thumpity thump, the long period below them. But if you're in the room with them, you'll hear the high frequency as well, because high frequency gets filtered out. So the further you are away, automatically it's going to feel more rolling. Let's switch to December 20th of last year. That earthquake, the rupture started near False Cape, just offshore, and then proceeded to rupture towards the coast, towards Hydesville. So we have a fault that's roughly 10 miles in length, and that rupture is moving right towards people on the coast. Rio Dell and Ferndale got really strong accelerations. Petrolia got weak. It was weaker in Petrolia than it was in McKinleyville. Why? Because Petrolia was at the back end of the rupture, and the rupture was moving away from Petrolia. Most of southern Humboldt, it was not terribly strong, certainly much less than what people felt to the north. So the bottom line is, don't assume that the next earthquake is going to be like the last one. It all depends on location, 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 and how that rupture propagates.
The one in 2010 that I experienced when I was in the barn in freshwater, rocked my car back and forth, front to back on the wheels. I'd never seen anything like it. It was my first one here. So I don't know what direction that was going, but that was my
That one
first
actually
experience.
ruptured to the offshore. So
it did to the offshore. Yeah.
Started just offshore of Eureka, and then it proceeded to rupture further offshore. So it was moving away.
It was fascinating because the barn shingles rattled and my car is going back and forth. It was headed east to west.
Yeah.
I couldn't tell where it started, but it was rocking. It was positioned east to west.
Okay.
So that was rather fascinating for my first experience. Okay. And you had a question, Elliot?
Yes. First, I'm looking for a good resource to read up on the Farallon plate. And from what I understand, not the subduction zone, but the San Andreas fault is propagating over long periods of time north. And so eventually we're going to be overrun by the San Andreas fault and not have a subduction zone. I wonder how much time that'll be.
Okay, there is a wonderful animation. If you just, if you use your browser to search Tanya Atwater plate animation, it's at UC Santa Barbara, you'll find a whole bunch of links showing the evolution of the plates over the last 80 million years and the last 40 million years. Sometimes I include it in my talks. Today I decided not to. The Farallon plate is the mother of the Gorda plate and the Juan de Fuca plate. They're actually the remnants of what was once huge, which once covered much of what we call now the Pacific. And for probably over 100 million years, the entire west coast of North and South America was a subduction zone boundary, very much like what you see along the Andes today. So over time, the rate at which the subduction zone was consuming the Farallon plate, excuse me, was faster than the rate that the plate was being created. So the ridge kept moving closer and closer and closer to the coast. 40 million years, 35 million years ago, it hits roughly near where Los Angeles is today. And at that point, as soon as the ridge hits the subduction zone, there's no strength on a ridge to pull the other side down. And at that point, the subduction zone dies. At that point, the San Andreas Fault is born. As more and more of the ancestral Farallon plate is subsumed in subduction, the San Andreas Fault keeps getting a little longer. By about 10, 12 million years ago, it's made it to the San Francisco Bay Area. Or 10 to, yeah, before present. About 5 million years ago, it makes it to Clear Lake. And a million or so years ago, it parks itself roughly where it is today. 20 million years from now, it'll be somewhere along the Oregon-Washington coast. And 25, 30 million years from now, there won't be enough of the Farallon plate lasted at all. It'll be completely gone. So good news in the future. We don't need to worry about that as a threat. But it's a fun animation.
Thank you.
Sounds great. Anne has another question.
More like a statement and question of awareness. Morris Graves' home, south of CR, has that lake that
Yes.
my understanding is native opinion was that was caused by an earthquake. It's deep. It's almost looked black. It's weird. It's not a natural lake.
Well, I've not been there. I'd love to go there. Get me in sometime. I'd love to see it. But we see a number of features that are certainly related to this compression. Near Hydesville, there's certainly what we call sag ponds. Fault motion tends to, you tend to get erosion of the softest materials, and having isolated water bodies is quite common in fault zones. You see it all up and down the San Andreas Fault. So I happen to now be quite a believer in oral history, and it is so unfortunate that the oral history has been so disrupted, because had we spent a bit more time talking with the WIOT elders, we would know so much more about the history of the Humboldt Bay region.
Okay, Jim Adams asked the question, and we're going to try to give you a break because this has been long. What is the sub-seabed geology like off Humboldt Bay? Is it rocky or composed of mud flats? How deep are they below the seabed?
Well, that first slide I showed you, or one of the earlier slides, is showing you the depth of, so if you, once this is back online, you can go back and look at this presentation. The slide where I'm talking about plate tectonics is giving you the depth to the seafloor. And the Gorda Basin is very shallow. Lots of thick sediments. Most subduction zones have a very clear trench where you can see that the seafloor is deeper right at that margin. The margin of Cascadia has no trench. because the sediment production from rivers like the Eel and all the rivers going up into Vancouver Island are so busy eroding sediments that you don't see any physical expression of a trench there. So thick sediments is pretty much blankets our offshore area.
Okay, Nancy Stevenson asks, how do you decide to either run outdoors, you say it's more dangerous, or evacuate ASAP? I mean, stay indoors or evacuate.
Okay, first of all, you never ever run outdoors. And I'm glad you mentioned this because we've had 3 really nasty earthquakes in 2023, not up here, but we've had one in Afghanistan, we had one in Turkey and one in Morocco, all of which killed more than 2,000 people. And you look at the pictures and you see rubble everywhere. And on the news, you get reports from people saying, I only survived because I managed to run outside. Please don't take that as this is what you do in California, because unless you live in an adobe structure without any metal reinforcement, if you live in an adobe hut, okay, go ahead and run outside. But I don't think you do. Wood frame structures, reinforced concrete structures. Almost all of us live in wood frame structures. The way you are most likely to be injured or hurt is running outside. We saw that at the Bayshore Mall in 2010. All of the injuries were due to people running. If people had just stayed put, we wouldn't have had any injuries at the Bayshore Mall on that Saturday. When you put this together with tsunamis, what we say is, if, first of all, this is only if you are in a tsunami zone. So if you live in areas of the Samoa Peninsula or King Salmon that are in a tsunami zone, and it's a tiny percentage of Humboldt County that's, and Nancy, I know where you live, you're not in a tsunami zone. It would take an asteroid to get a tsunami there. But, and then all bets are off. But in that case, again, you feel an earthquake, you want to protect yourself from the shaking. Once the shaking has diminished to the point where you feel you can safely walk, then start your evacuation process. Get yourself, but you need to have practiced ahead of time. You need to know where you're going, and you don't need to go very far. All you have to do is go to the Redwood Coast Tsunami Work Group website. There's an easy link to an interactive tsunami hazard map. You can put in your address. You can put in your kid's school's address. You can see where the tsunami zone is relative to you. And then you only need to get basically from the yellow area, potentially at risk, into the green area. And the good news for us in Humboldt County is that we really don't have nearly the tsunami threat that they have further north. Del Norte, yes, bigger tsunami threat than we have, and along the entire Oregon and Washington coast.
Indigo asks, given the history, the Native American history, was Humboldt Bay formed in 1700 with that giant earthquake and tsunami, or earlier?
We actually have geologic evidence that Humboldt Bay is continuously remaking itself. We see evidence of at least 5 sudden submergence events in the Mad River Slough. So one of the things I often used to do on geology field trips, we took a little core and we put it down into the mud at the Mad River Slough, and we pulled it up, and you could very easily see deep bay muds, and then suddenly you'd see another peat layer, a layer that is absolutely like the current peat layer at the top. So what we see in the geology of Humboldt Bay, both Arcata Arm and South Bay, Jay Patton did his master's thesis in the South Bay, is repeated events, not regularly, sometimes as close together as a few hundred years, sometimes as far apart as 800 years, where the bay suddenly jumps down 1.5 feet, 2 feet. And if you realize that the bay, if you don't dredge it, tends to be really shallow, suddenly dropping down 1.5 feet will look like suddenly it's a great big bay. So the Wiyot narrative of the bay being created in a single day probably related to the most recent drop, maybe 1700, but in their oral history, it probably recurred. And unfortunately, much of that oral history has been lost. Can't hear.
That's a problem. Sorry.
Yeah.
Alderon asks if there's any good source for Wiyot and Yurok oral history regarding earthquakes and tsunamis.
Yes, and in fact, we have resources posted on the Camomay website. So if you just use your browser to do camomay.humboldt.edu, there's a section called resources for teachers, resources. We have several articles, not only on Humboldt Bay area, but the entire Pacific West on how oral history is important. You're gone again.
Thank you. I'm trying to be polite, not have you hear my noise from this end. I keep asking the Joanne McGarry indicates she keeps asking the city of Arcata if our community is prepared for those of us who must evacuate our homes in areas of the city. Are there supplies, uphill and designated places to find shelter and food and first aid? I live in the Creamery District.
I can't answer that. You're going to have to ask the city of Arcata. That's not, I don't have any direct relationship with responders at this point in my career.
Okay, and does anybody else have a question? Otherwise, we need to let Lori attend to her cold. But I do have one question. With the discussion of constructing more 5, 6, 7 story, 4, 5, 6, 7 story buildings in Eureka and or the city of Arcata, are they paying attention to the soils that they have underlying the cities and in making those decisions, and are they listening to expertise on those issues?
Well, first of all, in this day and age, to build any structure, especially one for multiple habitation, you've got to go through a state procedure. So you can't just willy-nilly go put something in. If there's a liquefaction hazard, you are mandated to put in deep foundations. There's no problem in designing structures to withstand liquefaction or strong ground motion. It can easily be done. You could put in a 20, 30, 40 story structure if you build it according to engineering requirements and understanding the soil load. That's completely doable. There are all kinds of issues that have to do with population concentrations. It's quite likely that area is going to subside in the next Cascadia earthquake. So you're going to be dealing with a large population of people that are displaced. And it is currently right at the edge of the tsunami hazard zone. In 2 decades, it'll probably be well within the tsunami hazard zone. So there are a lot of less clear issues. I'd say the engineering issues are very straightforward. We can do it. I'm not saying you want to do it, but we can do it. But the things that aren't really written down in clear requirement codes in terms of how do you get people to evacuate and get out of the area. I've heard some people say, oh, well, they can just evacuate in place. I spent quite a bit of time after the 2011 tsunami in Japan talking with survivors, people who were forced to evacuate in places like the Sendai airport. You think, oh, that'd be a pretty good place to be. They were there for 4 days. That doesn't seem like that long. Well, it turned out there was like no, after they ate all the chocolate candies from the gift store, there was really nothing to sustain them. Sleeping on cardboard. I mean, it was terrible. You really don't want to vertically evacuate unless there is no other option. I would absolutely never live in a place where I thought I might have that vertical evacuation was my only option, because I've just heard too many horror stories of how awful, even if it's only a few days, the longer it is, the harder it is. You really want to get out of that hazard zone if you possibly can. I mean, obviously, if there's no other choice, that's okay. But these are all bigger issues that you really need to think about. And of course, there are all kinds of issues with sea level rise and so forth that have to be taken into consideration.
Lori, we've kept you talking a long time, not just with your talk, which was wonderful. And as Elizabeth Morrison said, thank you for this talk. It's fascinating, and it truly is. This was an incredibly good talk. And we really appreciate the whole background that you've provided and our understanding of how it affects our area. So I want to thank you, along with everyone else, for coming, and mention that on October 16th, Sophia Pereira, our public health officer, director, will be talking about Live Well Humboldt, the community health improvement plan, how this community-wide initiative across multiple sectors of the county will increase equitable opportunities for health and well-being in our community. We welcome you back next week. Thank you all for coming, and please do, if you aren't yet a member of OLLI, consider joining up. We'd love to have you and bring friends. You know, we need to get that number over 1,000. So
And sign
thank
up
you.
for Shakeout. Shakeout, 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 Shakeout. Yay!
That's good too.
Shakeout.
Yay! It'll be in the paper, I'm sure too, right?
Yep.
You had it in the paper. You had it in the paper today, Sunday. So thank you all for coming, and we will look forward to seeing you next week.
Thank you so much, Lori.